The next question asks us to sketch the reinforcement in the staircase. We have done the design of staircase previously. Our following steps is to consolidate all the specifications and the design outcome in the staircase detailing. First, you need to get the dimensions of the staircase. It is given in the question. Based on the locations of the grid line, the spans are given. The riser is given as 750. The going is 250. Thickness of the staircase is 175. The locations of the beams are indicated. We are designing half of the staircase from the ground floor to the intermediate landing. The other half, it will be the lubrications of the detailings for this. For that, we just shows the detailings for this part of the staircase, following the grid line and the dimensions, the locations of the beams, the thickness of the staircase, the going, and also the risers. Next, we need to get the main reinforcement. Based on our previous design, the main reinforcement, it will be Y16 350. As for the secondary reinforcement, it will be Y10 400. The main reinforcement, it will be the reinforcement longitudinal to the span. Since the supports of the staircase are here, that means the staircase is subjected to bending in the longitudinal directions. There are no supports for the sideway. That means you're going to expect there will be no moment to be taken in the transverse directions. Now the main reinforcement, it will be Y16 350, whereas the transverse reinforcement, it will be Y10 400. You may apply to all throughout the entire staircase. For the bottom bar, you will have the arrangement in this manner. The longitudinal rebar will be placed closer to the soffit, whereas the secondary reinforcement, it will be on top of the main reinforcement. You will also need reinforcement at the top of the staircase, especially the regions near to the support. You know that the concrete is cast monolithically to the beam. That means you're going to expect certain degree of the negative moment at the support. That's why you have to provide the top reinforcement at the support. When you provide the top reinforcement at the support, the arrangements of the main and secondary rebar, it will be the opposite to the bottom reinforcement. In order to maximize the moment resistance capacity, you would like the main reinforcement to have the largest possible effective depth. For the top reinforcement bar, the effective depth is calculated from the soffit of the staircase. As a result, this will be the main reinforcement and this will be the secondary reinforcement. Normally, when it comes to the arrangements of the reinforcement, staircase require both top and bottom reinforcement. You can do curtailment in order to save the amount of reinforcement, similar like slab. When the design does not require any compression rebar, you can release the amount of reinforcement. Now the question here is, where shall the reinforcement stops? To be frank, I do not have the exact answers, as I haven't encountered any reference mentioning about this. Nonetheless, I can provide you some perspectives in determining the required anchorage length here. First, you may observe from the bending moment diagram, especially the regions at the support here. You will see negative moment at the support, and you know that the existence of the negative moment will require top reinforcement near to the support. Now, if you wish to know where should the anchorage end, most likely you can consider the anchorage should end at the zero moment. This is one of the possible considerations when you decide the layout of the top reinforcement. Also, you can view this in the perspective of the industrial practices, considering the staircase as a typical slab. For a typical slab, these are the recommended curtailment. It is specified here the required length of the curtailment. Let's say for the end span, we are talking about 20% of the end span. The provided anchorage length at the end span should be at least greater than that 20%. As for the intermediate span, we're going to look into three possible components. First, it will be 1/3 of the span itself. Second, it will be at least 1/3 of the adjacent span. And then third, it will be at least 50 times the bar diameter. Now the question here is, the slab is arranged horizontally, whereas the staircase is arranged diagonally. Now, how do you define the anchorage length? You may adopt the concept of 50 times the bar diameter. The required anchorage length, it will be defined by at least 50 times the bar diameter. Same goes to this. The 50 times the bar diameter, it will be towards the longitudinal directions of the reinforcement, as you're going to expect the reinforcement to be subjected to tension while resisting the moment at the support. As for the 1/3 of the span requirement, first we are referring to this span, which is the summations of 1.275 meters and 3.075 meter. The effective span is determined by the locations of the beam as the support. Now the 1/3, it will be defined by the 1/3 of this particular span. Identify the 1/3 locations, draw a straight line, then that will be where the anchorage should stop. You can do the similar at the end span here, which is defined by 0.2 of the span here. That means you are quantifying the 20% of this entire span. Identify where is that 20%, draw a straight line, and then this shall indicate where the anchorage length should stop. Just that if you choose to adopt the principles of this, the 20% of the end span, the 1/3 of both spans, and at least 50 times the bar diameter. Now the proposed anchorage length of the top reinforcement bar shall be checked against the bending moment diagram for the staircase, especially when you deal with the intermediate support. You will need to make sure that the proposed anchorage length shall not be shorter than the locations where the moment is equals to 0. To make it simple, if you use the required anchorage length of at least 50 times the bar diameter, it shall be longitudinal to the arrangement of the reinforcement. Now if you choose to define by the percentage of the anchorage length, either 20% or 1/3, this will have to be in the directions of the anchorage length, and then you identify where it should stop. Based on the proposed length, you choose the longest, and remember to check against the negative moment from the bending moment diagram. Although the reinforcement is sketched in this way, it is possible for this setup here. Your anchorage length might end somewhere here. Personally, I feel it is okay, since this acts as one single span. You don't have to always have the negative moment here. However, if you are feeling lacking confidence, it is no harm for you to provide the anchorage length as a safety measures, consuming a little bit more reinforcement in the staircase. Such a design is still okay. Personally, in the industrial practice, even though the requirement of the anchorage it may end here, I will still provide more as the safety precautions. Especially, I am more concerned with the joint here. This may be the critical regions or hinging effect of the staircase. At the end of the day, the arrangement of the reinforcement may end up to be similar like this. One more thing about the layout of the reinforcement, especially for the landing here. If you see the arrangements of the landing beam, instead of having the landing beam here, now the landing beam happens here. This leads to a situations where this part end up to be cantilever. You have to be extra careful with the cantilever slab. For cantilever members, you will expect negative moment throughout the entire span. To ensure the stability of the cantilever slab here, which is the landing of the staircase, you need to provide sufficient top reinforcement. The bottom reinforcement may not be as important, but the top reinforcement, it will be very important for the cantilever members. Such a design varies slightly when the beam is located here. If the beam is located here, now no part of the slab will be cantilever. Then the bottom reinforcement bar are important, and you make sure you provide sufficient reinforcement at the support to take the nominal negative moment at the support. Next, we talk about the arrangements of the reinforcement. Let us zoom in a bit to see the reinforcement at the joint of the horizontal landing and the inclined flights. If you see the reinforcement, let's say the longitudinal reinforcement at the bottom of the landing, you need to make sure the longitudinal reinforcements to be also embedded in the flights with at least sufficient anchorage length. That means the reinforcement shall be bent so that it fits nicely to the inclined members of the flights. The question here is, when should this bend occur? Whether the bend occur here or occur here. Sometimes you see people design to have the bend here, but this is not the right way to do it. You need to first know the principles of having the reinforcement. The reinforcement is the strongest when it is in the straight line, as it is used to carry tension. When the reinforcement is embedded inside a member, the top priority it will be ensuring the reinforcement to be in the straight line as long as possible. For this main reinforcement, the longest span that you could go, it will be nearly to the end where it must bend, so that it fits nicely into the flights. In this case, you will extend the reinforcement and start bending here. Same principle applies to this longitudinal reinforcement from the flights. Again, you would like to keep the reinforcements to be straight as long as possible. That means when the reinforcement of the flights entering the landing, it should continue its path until reaching to a state that it will have to bend, so that it fixing the landing here. Then this shall be the locations where it bends. It is not recommended for you to have the bending occur here and then coming here. To make it simple, this is how the reinforcement layout look like. However, such an arrangement of the reinforcement bar have a problem. This is where the reinforcement bar meets. Ultimately, if without strengthening of the other reinforcement, a hinge can occur here. This is likely to be the most vulnerable point of the staircase, and the staircase can fail because of this. Now, in order to prevent the hinge failure here, you will need this reinforcement in order to carry the tension here to prevent the hinging failure here. The next question it will be, how long will this reinforcement bar to be? What is the required anchorage length? Again, I do not have the standard answer. Personally, what I will do, it will be again following the rules here. Either 1/3 of the span or at least 50 times the bar diameter. For the things that you are not confident, normally you will go for a more conservative measures. This will lead to higher consumptions of the material, but at least it is safer. Bear in mind that this reinforcement bar is very important to prevent the hinging failure due to the arrangements of the reinforcement bar here. Same principles apply to this joint here. When you have a horizontal landing joining with the diagonal flights, we adopt the same principle. Arrange the reinforcement in this manner, where the reinforcement should only bend when it has to, as it is reaching to the limit of the concrete edge. We don't simply bend reinforcement bar in the concrete. However, such an arrangement can lead to a hinging process here. In order to prevent the hinging failure, we provide tension reinforcement bar here. And this tension reinforcement bar has to be continuous. This is not two pieces of reinforcement bar. Instead, it is one single reinforcement bar bent at this angle. Again, the required length here. Probably you can adopt the principles here. With that, you have the reinforcement and the dimensions of the staircase, including the grid line and also the span, clearly indicate for the contractor to construct the staircase. At the moment, personally, I am unsure the exact anchorage length that should be provided here if in accordance to the standard, due to my personal limitation. To overcome this, normally I will go for a more conservative measures, which leads to higher consumptions of the material. At least it feels safer. Now, if you happen to know how to determine where should the reinforcement end, do let me know. Your selflessness is highly appreciated. Now, this concludes the design of this staircase as a revision to you to prepare your final exam dealing with this staircase.